Hi, welcome everybody for the last session of second day of the conference. We are going to have a second keynote by Professor Onos. This talk will be for 60 minutes on why does Ramanujan, the man who knew infinity, matters. This session will be chaired by Professor Suri. And we will keep around 15 to 20 minutes at the end for question answer. So keep posting your questions on the chat box. Thank you. Over to you, Suri.
Okay, good evening, everybody, and welcome, Professor Onos. So, as you have seen the title, Professor Onos is a Thomas Jefferson Professor of Mathematics at the University of Virginia, and you can. Oh, got it. Okay. So, I just want to say a few things about his contributions. So, his contributions include several monographs and several research papers and popular articles also in number theory, combinatorics, and algebra. So, as you can see from the title, his mathematical contributions are intimately connected with Ramanujan's name. I'll just mention a few. For those who are not aware, you know that Ramanujan's theory of partition congruences was expanded vastly in the year 2000 by Professor Onos to produce infinitely many such congruences. The 2009 Sastra Ramanujan Prize, which is usually awarded to a young mathematician under the age of 32, was awarded to Catherine Brinkman for her work jointly with Onos. Professor Onos has also received many awards for his research. I'll just mention in April 2000, he received the Presidential Career Award from Bill Clinton in a ceremony at the White House. And in June 2005, he received the National Science Foundation Director's Distinguished Teaching Scholar Award and several others, Sloan Fellowship, Packard Fellowship, Guggenheim Fellowship. And in 2002, he became a fellow of the American Mathematical Society. I should also mention in 2011 and 2015, Professor Onos gave TED Talks. So he also stars in the 2013 docudrama Genius of Srinivasa Ramanujan. He is profiled in the May 2014 issue of Scientific American. He was an associate producer and the mathematical consultant for the movie The Man Who Knew Infinity, based on Ramanujan's biography, which is of course written by Robert Knigle. In April 2014, Onos and two others had found a framework for the so-called Rogers Ramanujan identities. This sort of solving a long-standing mystery stemming from the work. Their work remarkably made world news that year and was ranked 15th among the top 100 stories of 2014 in the Science in Discover magazine. So finally, I just want to mention one last thing about the Riemann hypothesis. In May 2019, he published a joint paper with Zagare and two other students. Their work proves a large portion of the Jensen-Polya criterion for the Riemann hypothesis. So, finish by saying in recent years, he has resumed his athletic training as a runner, swimmer, and cyclist. Since 2002, he has competed in triathlons as a member of Team USA. If you permit me, I would like to share one last screen. Let me just see if I can share it. Let me see. Yeah. Can you see anything? Yeah.
Yes.
Yeah. So this sort of exemplifies his manifested career. You know, in the middle you see the partition function congruence, one of them, and he sees him cycling and scuba diving and several other things he does. And I am happy that one of my ex-students who did bachelor's and master's in ISI, he's working on his PhD with Professor Onos. And without further ado, I now give it to Professor Onos to give his talk.
Sorry, we don't see your screen. I mean,
it is.
I don't see. Yeah. Can you see now?
No.
Okay, so this is on his web page. I'll stop sharing and again share. I think.
Okay.
My computer is very slow, so this is on his web page. If you can go and see his. Unfortunately, it is not moving at all now. Let's see. I should say that I've changed my computer. This is an old computer. It's not working. So I'm sorry. So maybe you can just go to the web page at some point. Look at his web page and they see this beautiful picture of him going on a scuba dive and also cycling, and something about partitions. So he sees sort of diverse interests and will be, I'm sure, inspired by that. So without further ado, I'll just ask Professor Ono to uh, start his talk. Professor Ono?
You have to
You'll
stop
have to
sharing.
you'll have to unshare your screen so I can start.
Yeah, I'm trying to do that. Wait. My computer is stuck.
Okay.
You may need to leave and come back, Suri.
Yeah, that's what I'm planning to do. That means my computer is not even moving.
I
Otherwise,
just
I have to be removed, I think.
I just did. Can you?
Yeah. Please remove me and
Oh, how unfortunate. Very unlucky. Well, good afternoon or good evening, everyone. I come to you from Virginia, and can someone let me know if they can hear me? Do you hear me?
Yes, we can. Clearly.
Okay, great. Well, thank you very much, Professor Suri, for your very kind introduction. And I see several very familiar faces. I don't have time here to say hello to everyone, but thank you for having me. It's always a great honor to talk about Ramanujan. And so let me begin by saying that if this wasn't the year or 2 years of COVID, I would have very much preferred to have joined all of you in person, but this is the world in which we live. And so let me do my very best to virtually be with you today through this lecture. So the story of Ramanujan for me personally begins a long time ago. I was a high school student in 10th grade in the mid 1980s, growing up in Baltimore, Maryland, when I first learned about the man Ramanujan. And before that, I knew nothing about Ramanujan, just a little bit about myself. My parents are Japanese. They came to the United States after World War II because my father was offered a tenure track position to conduct research in mathematics. And he recently retired from Johns Hopkins University. He too was a number theorist. But what you heard me say was that my parents came to the United States after World War II. World War II was a very difficult period in the world. Japan was notorious for their participation in the war. And as I'm sure you know, Japan and the United States were bitter enemies in the war, in that war. And so it might come as a surprise that the first place that my parents would move would be the United States and end up raising a family here. So with that as my historical background, there's a lot that actually needs to be explained and remarkably is related to Ramanujan. So this letter that you see on the screen came to the house when I was in 10th grade. You can see the date, March 17th, 1984. And I fished the letter out of the mailbox and I gave it to my dad, thinking this is a peculiar envelope with exotic looking stamps. I've never seen anything like it. And a few hours later, my father comes to me in tears and shows me this letter. And he says, I have to tell you this most amazing story. You might not believe it, but this story has everything to do with why we are able to lead a very comfortable life. So what does the letter say? It says, "Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you have contributed for the sculpture in memory of my late husband, Srinivasa Ramanujan. I am happy over this event, and I thank you very much for your good gesture and wish you success in all of your endeavors." And for me, even though I was basically still a child at the time, I knew that this was a letter that must have been sent to perhaps 100 other people. You see, my father, it turns out, had contributed $25 to help commission a sculpture in the image of this man named Ramanujan. And so I thought it was very peculiar that this would evoke such emotions in my father. And what I learned later was, well, there's a lot to this story. In 1980s, my father said Ramanujan was an amazing mathematician. And he wasn't the kind of mathematician that you read about in the books that we teach in high school in the US. He was an autodidact. He was self-trained. And on top of that, he was a 2-time college dropout. And even on top of that, he left behind formulas and notebooks that mathematicians to that day, and even to this day, were still trying to figure out. And I found that very shocking. In 10th grade, the last thing I wanted to be was a mathematician. I was like probably most other high school students, trying to figure out what we want to do with our lives. And at that time, I would have told you the last thing I want to be is a mathematician. And in particular, for me, mathematics meant pursuing perfect test scores, pursuing strong grades. And what came as a surprise to me is that my father, who supported getting strong grades, who thought it was very important to get high test scores, he was the one telling me about how amazing this 2-time college dropout was. And as a student, that was very important. So this lecture is about why does Ramanujan matter? And even before knowing anything about his mathematics, and even before knowing anything about his scientific legacy, Ramanujan mattered to me as a role model, a figure who overcame obstacles which to me would have seemed insurmountable. If you're interested in any of what I've just described, my friend Amir Axel, who died in 2015, we wrote together this book called My Search for Ramanujan. This was his idea. And I basically, with Amir, described my personal relationship with trying to explore the meaning behind Ramanujan in my life and the meaning of Ramanujan in the lives of mathematicians who have been influenced by him. But primarily, this was my collection of stories. As you have now, and maybe you have seen this film, because of my connection to Ramanujan, perhaps the most exciting opportunity I would have, the most exciting opportunity that I've ever undertaken in my life is due to Ramanujan. And about 7 years ago, the Pressman Film Company approached me with the idea of participating in a film project about Robert Kanigle's book, The Man Who Knew Infinity. And at first I was supposed to be an assistant to the art department, helping them assemble mathematical props. And one thing led to another. And by the end of the day, I was promoted to a level of an associate producer. It's one of the most exciting things I've ever participated in. And I'm truly blessed to have been part of that project. On this project, part of my job was to help train the actors to portray mathematicians. And I think we did the best that we could, and I think we did very well. And I'd like the audience to know that there were many hours of rehearsals, which began with me giving lectures, pretending to be Hardy, me pretending to be Ramanujan, at least to the best of my ability. And then the actors would mimic what they saw in my language and my choice of verbiage and my body language. And if you've seen the film, The Man Who Knew Infinity, and you get the sense that there's that there's this genuine portrayal of what it's like to do mathematics, we are very proud of that. And I'm particularly delighted that this meant a lot to the director and the actors. They wanted to be Ramanujan and Hardy. Of course, Dev Patel looks nothing like Ramanujan, but this is Hollywood. But I hope you would agree that that it seemed pretty real. Why does Ramanujan matter? I've already given you one answer. He mattered to me as a high school student trying to figure out what I wanted to do with my life. Through just the mere story of a man who overcame incredible obstacles, was a dropout, failed out of college, but who overcame these obstacles because of sheer hard work and the value that we place in creativity. And so, well, you can take that answer to the question why Ramanujan matters to yet a higher level. So after our film completed its theatrical release, I was very surprised in 2016 when President Obama and his staff at the Office of Science and Technology Policy at the White House contacted us. And if you know, 2016 was quite an auspicious year for us in the United States. This was the year of the presidential election between Hillary Clinton and Donald Trump. Without going into politics, let me just say that I wasn't very happy with how things turned out. That's the understatement of the year. But the point I want to make is that entering that presidential election season in 2016, President Obama held a series of events called transition events, where he invited to the White House the transition teams for the leading presidential candidates. You see, once you are elected president, you don't know necessarily how to be president. And so it turns out that there was a tradition until recently. There had been a long-standing tradition where outgoing presidents invite the leading candidates for the next presidency to train the inner workings of the White House. One of these days of events was devoted to science and education, very much like the conference that you're attending today. It was shortly before Halloween, and Obama said we should have the scientists come talk about all of the things they do, and to highlight the day or to end the day, let's have a social activity. Let's have a banquet. Let's have a reception at the White House celebrating the importance for the need in supporting education, in particular in the science and engineering fields. And I was delighted. France Cordova, who was then, she's here on the left, she was at the time the director of the U.S. National Science Foundation. She assembled a panel of people to discuss science. I was on that panel to talk about research and mathematics. And together with Obama, they decided, let's screen The Man Who Knew Infinity as the social event for all the scientists and the presidential transition teams when they come to the White House. And it was a huge honor. And at the time, I didn't understand why that was the case. And I learned later that this was Obama's thinking. Obama's thinking was that it is vital for the future of mankind that we collaboratively invest in education and science research. To him, that was obvious. And to be successful, to overcome the many challenges that we face, back then, like now, we were discussing climate change. We were looking for the cure to cancer. This was long before COVID, but I think these predictions have borne themselves out. Humanity faces many scientific challenges. And so what Obama said was, well, to be successful against these major issues, these global challenges, we need scientific and international collaboration. And to emphasize that point, he said, there's this film that I just saw called The Man Who Knew Infinity, where a large part of that story was an Indian mathematician collaborating with, and he was the genius, collaborating with a distinguished English mathematician to prove some theorem about primes or partitions, as Obama said it. And he said, let's show the film at the end of this period to emphasize what can be achieved when people from two very different backgrounds, scientists from very different cultures, get together to attack difficult problems. And at our little film, we were really touched by this overture. And so, of course, we did it. And that's what you're seeing in this image. This picture is a picture of me with actor Jeremy Irons, the NSF director on the left, France, and my friend DJ Patil, who at the time was the chief data scientist for the United States. And before the airing of the film, we live broadcast this problem to the citizens of the United States. What is the smallest number that is the sum of two cubes in two different ways? And so there you have it. Why does Ramanujan matter? Because his story and the part of the story that involves pursuit of challenges in science, together with the need for supporting international cooperation, that spoke to the previous president, and that was very much in the air back in 2016. So I don't have to tell you, this group very much about Ramanujan's life, but I do have to talk about it, not because I need to inform you about things you know, but more importantly, it's for you to hear how I, as a Westerner, view Ramanujan's life. So for me, well, here's a fact. Ramanujan was born in the late 1800s in South India, the state of Tamil Nadu. He was born a Brahmin, which we usually refer to as the educated or priestly caste. And what won't come as a surprise is that as a young boy, he was an outstanding student, winning academic scholarships and winning awards. This is what you would expect of people with supreme talent. What you don't expect, and this is where Ramanujan stood out very early on as being unique, is that he already did a lot of mathematical exploration on his own because he loved symmetry and patterns and formulas. And we've come to understand that he discovered much of trigonometry only by himself, only to learn later that he was discovering facts that had been discovered long before him. Instead of being discouraged by that, I'd like to say that this is evidence of the fact that some people are born with a gift. Of course, he had a gift for finding formulas. He had a gift with manipulating mathematical expressions, but such gifts don't amount to much unless there's this inner passion that drives you. Ramanujan, as a teenager, received a gift later. It's a book. It came in the form of a book called A Synopsis of Elementary Results in Pure Mathematics by G.S. Carr. This is not a great book. This is a book that English tutors use to help prepare pre-college students for college entrance examinations. But never mind all of that. This book was really quite transformational for Ramanujan as a young boy. This book contains enunciations of over 6,000 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. This book ignited Ramanujan's passion for mathematics, and from that day on, he would not be stopped. Following the format that he found in this book, he began to assemble his own notebooks, which he filled with his own formulas. And if you travel to Chennai, go to the University of Madras Library, you can ask the librarian and they will bring out for you these notebooks. So here's a photograph from 7 or 8 years ago, where together with my friend Raghuram, who is a professor at ISER Pune, we are flipping through Ramanujan's notebooks. And I've done this now several times in my life. And every time it's really quite a magical experience. These books, there's only 3 of them. So you might wonder, how much can you learn by flipping through 3 notebooks over and over and over again? And what I can only tell you is that every time I've gone back, whether it's in person or with the copies of these notebooks that I have on my shelf, I do feel like I learned something a little bit more. Often the sense is I missed something. You see, Ramanujan wrote these notebooks for himself. He didn't write them for us. And so the reasons why he recorded many of these formulas are not explained in the notebooks. They were in his mind. All we have in these notebooks is this mysterious sea of crazy looking equations that are all special for their own right. And for many decades, for well over a century, I think mathematicians have often been wrong when they thought they finally understood the meaning or importance or role of a particular expression. Well, because of this book, as I say, Ramanujan's passion for mathematics was ignited. This became his raison d'etre, his sole purpose in life. And as is well documented, he started to spend all of his time doing nothing but mathematics. And as a result, he flunked out of college twice. This is what we don't recommend that anyone do, but he did. He flunked out of college twice. He spent time in the temples listening to drums, doing math. He spent time on the porch of his home in Kumbakonam, on a street that has this very famous temple, the Sarangapani temple. And for me, And for Westerners, all of this imagery is really quite exotic and frankly is quite romantic, because the idea of where when you think deeply about mathematics, traveling to some other place in your mind so that the clarity of mathematical ideas becomes paramount, is something I think that research mathematicians understand and we seek to get. As I said, that's really kind of a romantic image for me, because it's very difficult to find that that moment, that perfect moment where the ideas you may be struggling with on paper in your mind come together in just the right way. And somehow when Ramanujan assembled his formulas, he had this uncanny ability to do this over and over and over again. And it should go without saying that he did this at a time when he didn't have the advantage of computers. He didn't have the advantage of the internet. All of this stuff that he was writing down was imagined, or as he told some people, were sent to him as visions from his goddess. Because he was a two-time college dropout, it was difficult for him to find a place in the world. But I like to say that he was the recipient of a very kind support. He found work as a clerk, the Madras Port Trust, and although he was not wealthy, he was able to make a meager living as a newly married man, and I think that is very important. Certainly for us in the West, in the United States, there's overwhelming pressure that is applied to high school students and college students so that they get into the right colleges, whatever that means, and then get the right kind of jobs or get admitted to the right kind of schools. And I fear that if we were to find a student like Ramanujan today, certainly in our schools in the United States, I'm afraid we would lose them. We wouldn't be able to find them, and then we wouldn't be able to help them. And that is a loss that I think we have to reflect on from time to time, because, well, what would have happened? What would the world that we live in be like today had Ramanujan never lived? Well, many areas of mathematics and physics would look very different. And there are applications of his ideas in cryptography and signal processing and so on, which maybe would have never happened. And that thought should be really frightening to us. Okay. The underlying fact is that Ramanujan was writing down formulas that people around him could not comprehend. And it's not just that the people around him couldn't comprehend the importance of his notebooks. There were no people in the world, basically, who could understand the importance of his notebooks. And as I think many of you know, and if you don't, there are famous mathematicians worldwide who have devoted their entire careers to making sense out of Ramanujan's notebooks, and that continues to this day. So if you've heard names like George Andrews, former president of the American Math Society, or Bruce Berndt, recently retired professor from the University of Illinois, those were two of the most important figures over the last 70 years, trying to make Ramanujan's mathematics accessible, as he saw it, to the world. Without them, also we would be very far behind. So in this lecture, I'd like to share with you some film clips because I think they're beautiful. And if you haven't seen the film, or even if you have seen the film, I'd like to share with you these clips from our perspective, the perspective of the makers of the film. I think you might find that interesting. So this first film clip I want to show you is a film clip where we have to achieve two goals. Our first goal is to explain that mathematics is beautiful. It can be beautiful. How do you explain that to an audience? And our other goal is to introduce a main figure, played by Devika Bizet, the character Ramanujan's spouse. So let me play this clip.
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. Maybe there is someone else who can see and understand it as well. And for them, it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In math, these patterns reveal themselves in the most incredible form.
So there was that scene. And so our goal was to introduce these notebooks in a way where the audience could see that to mathematicians, the ideas, the formulas, we wanted the audience to think of them just like poets think of poetry, or musicians speak of composing their rhythms and such. So at that particular point in Ramanujan's life, he was working in his mind in isolation. And imagine how difficult that would be. In many ways, the world is similarly isolated today, largely due to COVID. I'm unable to be with you. And so despite that, we find a way to get together. We are having these Zoom sessions. But for Ramanujan, there was no such thing. He didn't have that community of scholars who could both inspire and appreciate his work. And so Ramanujan was in a situation which I would have thought to be really quite desperate. And through the urging of friends, he decided to reach out to some mathematicians in the world. He wrote letters to many distinguished folks, and most were not responded to. However, Ramanujan did write a letter famously to G.H. Hardy, which is the beginning of everything that we now know in terms of Ramanujan's legacy to the world. He could have been lost. Ramanujan's letter begins with these very lovely and famous words. I beg to introduce myself to you as a clerk, very humble. I've had no university education. I've not trodden through the conventional regular course, but I'm striking out a new path for myself, and the results I get are termed by local mathematicians as startling. What followed in that letter were many pages of formulas, some wrong, some well-known, but most that were so unique in their presentation that over the course of a few days, G.H. Hardy came to recognize that the author had to have been someone with immense creative abilities. So here is a picture of G.H. Hardy on the left. It's very famous. And on the right, we asked Jeremy Irons early in the shoot to replicate this pose. And so I blew up the picture on the right to give you a sense of how gifted Jeremy Irons is in terms of his facial expressions. And despite the fact Jeremy Irons was much older than Hardy at the time, I think we cast the perfect actor to play G.H. Hardy. There were some things that Ramanujan wrote down in this notebook, which at first glance might seem absolutely absurd, but to the experienced mathematician would be viewed as brilliant. This is a very famous example. It's the statement that the sum of the positive integers, 1 plus 2 plus 3, instead of being positive infinity, is not even positive at all. Ramanujan claimed is the small negative number, negative 1/12. And most people would agree that this is wrong. And in fact, every professional mathematician will say, yeah, of course this is wrong. But to experts in analytic number theory, they will say, well, yes, this is wrong, but wink, wink, it's not really absolutely wrong. It's actually a statement that could be reformulated into a precise statement, which is actually correct. And the depth of that mathematics has to do with the interpretation or this reformulation. What I'm speaking of is the construction of what's called the Riemann zeta function, which is the stuff of the famous Riemann hypothesis. And it turns out that this Riemann zeta function is not well defined by means of ordinary calculus for all of the values in which you'd want to evaluate it. There's a method of analytic continuation that allows this function to be defined for all integers. And if you were to reinterpret that analytic continuation naively to mean that you're allowed to sum up the positive integers, then you would actually find that the value of this function would be negative 1/12. And Ramanujan, certainly in Hardy, found someone who could recognize the charming or perhaps really peculiar, almost truthfulness of this statement. So in the making of this film, it was absolutely vital for us, for the audience to recognize how startling this letter was. And so let me share with you this very beautiful scene between Hardy, played by Jeremy Irons, and his friend John Littlewood, played by Toby Jones, with regard to this letter. So how did Hardy view this letter? Let me show you.
You know, Littlewood, this year alone, I've received correspondence from those who profess to prove the prophetic wisdom of the pyramids, the revelations of the elders of Zion, and the cryptograms which Bacon supposedly buried within the plays of the so-called Shakespeare. But a letter from an ill-educated Indian clerk in Madras challenging assertions I made in the track series really takes the biscuit.
Well, I have to say, I've made similar assertions myself.
So you admit it?
But this was 3 years ago.
No, I'm talking about the letter. Bloody brilliant, I thought. I don't know where you got the postmark. Almost had me fooled.
I simply don't know what you're talking about.
Oh, come on. I'm not a complete idiot.
I don't know how to get this into your thick skull, but whatever it is you're talking about, I'm simply not involved. Play.
Sir, you've missed Hall.
Not hungry. I tell you, there is a war coming, no doubt about it. Because we are being led like mindless, spineless sheep. And no one bothers to question any of it. It's coming all right, you can smell it.
You're as paranoid as Hardy.
With all due respect, Bertie, you couldn't hold a candle. Littlewood, could I have a word?
Yes, of course. Integrals, infinite series, God knows what else. Oh, excuse me. I always forget you don't believe in a supreme being.
All right.
This chap turns out to be genuine. You might have to reconsider.
Oh, he must be genuine. Who'd have the imagination to invent all that?
Well, I'm rather flattered you thought I did. These two infinite series are the more intriguing.
Yeah, they defeated me completely. I've never seen anything like them.
Well, it's deceptive. I'll wager the hypergeometric series.
A great Littlewood stumped. He's Hobbes class, I'd say. Being inexperienced I would very highly value any advice you give me. Yours truly, S. Ramanujan.
What does the S stand for?
You can ask him yourself.
You intend to invite him here?
Well, no. Much better let him rot away in his office in Madras.
So there you have it. This was our scene where we wanted to emphasize that Hardy was genuinely shocked. Perhaps this was the most shocking event in his entire life. And if you're wondering, these formulas that he refers to as "I've never seen anything like them," that is not we did not manufacture those lines. Those lines were actually taken from text that Hardy himself wrote after Ramanujan died, when he was reflecting on his relationship and the impact Ramanujan had in his life. So he was speaking about what would later be called the Rogers-Ramanujan identities. So I haven't mentioned this because up to this point, perhaps as an oversight on my part, but let's remind ourselves of the period of time in history that we're talking about here. Ramanujan traveled to England in the early 19-teens, at a time where England was about to break out with the rest of Europe in a bloody world war. It was a very difficult time to be traveling anywhere in the world at that time. On top of that, and perhaps even more paramount, is the fact that Ramanujan was Indian, and India was part of this great, this huge, British English Empire, right? It was terrible, right? The English viewed India as one of its outposts, one of its colonies, someplace way out there. And as a result, there was overt racism that was exhibited between the English and the Indians. It was terrible. I don't have to tell you all of that, okay? And so what's really quite remarkable in the story of Ramanujan is that despite the fact that Hardy wasn't quite well-spoken, he wasn't a social elitist, he wasn't in the circle of people whose ideas mattered, he wasn't a social influencer. But what was important is that as a mathematician, someone who values ideas, Hardy was able to break through and recognize Ramanujan for his immense talent. It's really quite remarkable. I think most of the other English professors at Cambridge at the time would have literally been unable to see Ramanujan for his sheer abilities. And that's not a criticism, that's just a fact. But despite all of that, it has to go, and it cannot be unsaid, not mentioned, that there were major cultural and quite literally logistical obstacles that almost prevented Hardy and Ramanujan from succeeding as a scientific pair. So when we made this film, we had to make it very clear to the audience, remind the audience of what the world was like back then in terms of these issues. And so let me share with you this scene that represents, that depicts the first meeting that Hardy has with Ramanujan in his office. John Littlewood arrives, and let me just show you what the first meeting could have been like.
Ramanujan, we decided that for the good of everybody, you should attend some lectures.
But I'm here to publish.
Yes, all in good time, I hope. But first we need proofs of your work.
It's really nothing to worry about. It's simply a question acquainting you with the more formal methods that will benefit our future work together.
I mean, we need a common language. You wouldn't expect us to converse with you in Tamil.
No, but you expect me to speak English.
Quite. So, there'll be plenty of time for publishing.
I'm sorry, but with all humility, how does anyone know that? I don't want this to die with me.
I assure you it won't.
Thank you, sir. But I have much more to share with you. As I told you, the letter only contained a small sampling of my discoveries. You'll see I have even found a function which exactly represents the number of prime numbers less than x in the form of an infinite series.
Exactly.
Yes, I thought if we were going to publish, it should be something groundbreaking.
Well, this is most unexpected.
Hardy, this will take a lifetime.
Maybe two.
So there you have it. Even though Hardy and Littlewood were very surprised by the contents of Ramanujan's letters, it turns out that they had only seen a very small glimpse of the formulas that Ramanujan had collected in his notebooks without proof. And upon his arrival, this became clear to Hardy and Littlewood how much Ramanujan had, and they were shocked. And the point is that, well, there would be a period of transition where these two men, Hardy and Ramanujan, would have to figure out how they could work together. At the outset, Hardy viewed himself as the professor, meant to bring on his student, his mentee in Ramanujan. And you could see he was struggling to overcome the fact that Ramanujan is Indian and that he is this great British professor. But over the course of the next few years, their relationship clearly transitions. And by the very end, that relationship is of the following sort. Hardy comes to recognize that Ramanujan is really perhaps the most powerful creator of beautiful mathematical expressions that he had ever seen, and perhaps maybe only in the league of someone like Gauss and Euler. And so by the end of their collaboration, they were really teammates. They were really partners. And that transition is a very important part of this story. One of the reasons you see that Ramanujan matters is that Ramanujan also gives us lessons about how to teach our most talented students. People talk all the time about how to teach the typical curriculum, how to teach the students that have performance gaps to bring them up. But make no mistake, we also have to talk about how to train the most talented, the people who will be presenting ideas that propel humanity forward through the beauty and importance of their ideas. We cannot lose them. And so in the story of Ramanujan, one of the reasons Ramanujan matters is as simple as this. What if Hardy had not responded to Ramanujan's letter? What if Ramanujan had never been brought into the light? Where would we be today? And that is a thought that I don't even want to begin to fathom. And so the story of Ramanujan allows us, when we teach our courses or design our curriculum, to remember that they're students of all abilities and of all talents, with many different kinds of talents. And we have to do our best, and this is one of the major challenges in education, for doing our best with each of these types of students. All right. And the last scene I want to show you, I think, is quite beautiful. And I think I played a large role in getting the scene written. It's that the relationship between Hardy and Ramanujan was a very complicated one, as I said. If you have a student who really is gifted, who have this property where ideas come to them quickly, how do you inspire people like that, right? And let me share with you this scene about how Hardy inspired Ramanujan in a way which is actually very important for modern science.
How did you know that theorem?
It came to me. Mr. Hardy, I don't understand why we waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. Or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
Yes, but intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yep, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snatched from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like Euler. Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise, this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
So I think this is a lovely scene. Of course, when you have the opportunity to film in England, places like Oxford University and Cambridge University, the history and the architecture sort of makes the scenes beautiful, but I think the message is beautiful. Hardy in Ramanujan, his mentee, had supreme talent, incredible talent. And for Ramanujan was recording his formulas because he just had to do it. This is what he was meant to do. But what Hardy wanted to make Ramanujan understand was that with this talent comes some responsibility, because if you fulfill that, your potential, then in his case, the scientists of the future would benefit and be able to lay the groundwork for fields of mathematics and